In this section, we will learn methods for solving polynomial inequalities and rational inequalities. Because a polynomial is continuous, it can only change from positive to negative at its x-intercepts. We'll use this to our advantage to be able to find when an inequality is greater than or less than 0. We'll use a slightly different approach to solving these problems in the textbook. Our strategy for solving these inequalities will revolve around finding intercepts. So first step will be to express all terms on one side of the inequality, and then graph on your calculator and find the x-intercepts / zeros. For organizational purposes, we'll place the x-intercepts on a number line, creating several intervals, and then make note as to whether the function is positive or negative on those intervals, okay, meaning above or below the x-axis. We're going to then choose the intervals that correctly solve the inequality and write our solution in interval form. So example number 1, we're asked to solve and graph the solution on a number line for 2x squared plus x is greater than 15. So the first thing we need to do is express everything on one side of the inequality. So this would involve subtracting 15 on both sides, giving us 0 on the right. And on the left-hand side, there are no like terms, so we would have 2x squared plus x minus 15. So we need to find the x-intercepts. Lots of these you can find by factoring or the quadratic formula, or you can proceed like we did in the last section with our calculator. So we'd want to graph the left-hand side. So on your calculator, y equals, and we want to type in 2x squared plus x minus 15 and press graph. And we can see there's 2 x-intercepts. It's an x squared, so we're expecting 2 x-intercepts. Okay, and we can see here and here. So second, calculate 0. Left bound would be right here, somewhere over there. Enter. Right bound, anywhere down here. And at the guess screen, go ahead and press enter. And it tells us that x equals -3. Okay, so we've got -3 as one of our x-intercepts. And I'm going to go ahead and place that on a number line. Okay, our next x-intercept, right here, second, calculate, intersect, or sorry, not intersect, 0 is what I meant. Left bound, I'm scrolling to the right, and it's down here. And the right bound is over here. And we get 2.5, which as a fraction is 5/2. So there are steps 2 and 3. Step 4 is to make a note as to whether the function is positive or negative on these intervals, less than -3, between -3 and 5/2, and greater than 5/2. Okay, so if we look to the left of -3, the graph is here above the x-axis, so we'll say positive. Between -3 and 5/2, that's this part of the graph, it's below the x-axis, so we'll write negative. And for our last part, greater than 5/2, that's this part, and that's above the x-axis, so we'll write positive. Our last part of the problem is to now correctly identify which intervals solve the inequality. So if I look at my inequality, I want to find intervals that make the function greater than 0. Okay, and where the function is greater than 0 is when we saw on the graph where it was positive. So that's this one and this one. So x value is less than -3, and we'll write that as -∞ to -3. And as to whether you use a parentheses or bracket, same thing with linear inequalities. Look at the inequality symbol. It's a greater than, there's no equals, and so that would mean use parentheses. Okay, we have another interval that correctly solves the inequality, greater than 5/2, so a union, parentheses, 5/2 to infinity. Example 2, solve and graph the solution set on a number line. X cubed plus 3x squared is less than or equal to x plus 3. So like on the last one, the first step is to get all the terms on the same side. And so we'd want to subtract x and subtract 3, leaving on the right 0, and on the left x cubed plus 3x squared minus x minus 3. Again, a lot of these will factor, and you can solve for the x-intercepts that way, but if we're going to look at the graph anyway, we can find those on our calculator. So y equals, clear our last function, type in x cubed plus 3x squared minus x minus 3. And our graph looks like this, and we can see that there are 3 x-intercepts. Okay. Example 1, we looked at how to use calculating a 0. Let's refresh ourselves with the table method. Press second and table, and we can go through our list of x and y values. We're looking for 3 x-intercepts, and on my table I have 3, so I don't need to use calculating a 0 on this one. We've got x equals -3, y equals 0. So there's one of our x-intercepts. Another place y equals 0 is when x equals -1. And the third place, y equals 0, is when x equals 1. So we want to place those values onto our number line. -3, -1, and 1. And this has broken our number line into 4 intervals this time. If we go back to our graph, left of -3, the graph is below the x-axis, so we'll write negative. Between -3 and -1, that's this part of the graph, and so that is positive. Between -1 and 1, that's this part of the graph, that's negative. And past +1, that's this part of the graph, and that's positive. Looking at our inequality, we're wanting the graph to be less than or equal to 0, and so that would be less than -3, we were negative, and between -1 and 1, we were negative. So writing our intervals, less than -3, negative infinity to -3, and we have less than or equal to, and so we'll use a bracket because of the equals. Union, between -1 and 1, we were negative, so bracket -1 to 1. Second part of the instructions ask us to graph the solution on a number line. So just like with linear inequalities, expressing this on a number line, if I put 0 here, -1, 1, and -3. Less than -3, bracket, and shaded to the left. And between -1 and 1, bracket, shaded in between.